Okay, good morning, everyone. Again, my name is JP Onya, and I am one of the members of the Filipino Science Hub. And today, I'm going to talk about one of our passion projects here at FilSciHub, which is scientific research. And today, we're going to talk about the essential skills that our students need to develop in terms of experimental design in order to come up with a sound and fit for purpose experimental design. So let me just share my screen. Okay. So, well, at the heart of any scientific research is the research methodology or the experimentation part of that research project. And it's very important to take time to uh, think about the experimental design because this ultimately dictates the quality of our research results and the overall quality of the research itself. So at this point that we really need to um, give a bit of thought on how you carry out your experiments and what methodology you're going to use. So before I go on talking about experimental design, let me just zoom out a little bit and talk about the different types of quantitative research in which experimental research falls into. So one type of quantitative research is descriptive research, which merely describes an existing condition, describes the condition and characteristics of an existing population or sample of that population. So dito po, wala naman tayong control na or treatment na binibigay sa data. We're just merely describing that specific trait or characteristic of that population. For example, you have a population of students and you want to know the time that these students spent on social media, for example. So you can collect the data from a sample population, a sample from these students, and perform your descriptive statistics over that collected data. So that's descriptive research. While correlational research identifies relationship between two or more variables, also without control or manipulation. So dito po, we are trying to see if there is correlation or relationship between two variables, two or more variables, na wala kang ini-impose na control dun sa ating sample. So let's say, for example, that same set of students where you gathered the time spent on social media versus exam scores, or let's say for mathematics. So tinitingnan natin if there is relationship between time spent on social media versus the exam test scores, and see if there's a correlation or relationship kung if they spend longer time on social media, if this results in lower test scores or vice versa. So that's correlational research. While experimental research is dito na po tayo mag-impose ng controls or treatments on our samples, because this determines if there is a causal relationship between the variables. So we have the so-called independent variables, which we manipulate or control, and the dependent variable, where you take the results or the outcome of the manipulation on the independent variables. So in the end, you want to see if the controls that you did on the independent variable had an effect on the dependent variable. So that's experimental research, and that's what we're gonna talk about today. And one other type of quantitative research is the quasi-experimental research, which investigates causal relationship between variables when there is no random assignment of experimental subjects. That means yung experimental subjects po natin ay pre-existing na. But we want to see if there is causal relationship between that variables. Let's say, for example, there is a new teaching method that we want to see the effect on different groups of students. So these groups of students are already existing, and we just want to see the effect of that teaching method from one group to another. So there is no control as to the randomization of the students in those particular groups, or there's no control in the mixture or composition of those students. So that's quasi-experimental research. So let's now delve more into the experimental research. And the experimental design is the process of organizing the experiments to ensure that the right amount and type of data is available to answer the research question as clearly and as efficiently as possible. So yung experimental design po natin is deeply rooted on the research question that we have set out to answer. So depende na po dun sa research question natin kung gaano kalalim or how comprehensive we're gonna dive into the experimental design. Because it only answers what we have set out in the research question. And the experimental design should be engineered as clearly and as efficiently as possible para ma-fulfill po yung ating research objectives. And I have this diagram here. So our research is divided into these three parts. So yung research question po natin is the one that we are trying to investigate, and we break down that research question into research aims and objectives, and those aims and objectives are answered one by one by our experimental design. So somehow the experimental design is the tool that we use to answer the research question, and they are really tied up very tightly to each other. Okay, so let me just share an example. Let me just pull this up a little. Okay, so this is one research that came from the Philippine Science High School in Western Visayas, and it talks about the effect of powdered eggshells on the vegetative growth of Vigna radiata, which is your common mungo or mung beans. So they are trying to investigate the effect of the powderized chicken eggshells on the growth of this mung bean plant. So that's essentially the ultimate research question, and they have broken down this research question into these different objectives. So they have soil compositions with different amounts of the powdered eggshells, and they're trying to measure the stalk length, the root length, depending on the treatment given to the different plant samples or the different content of the eggshells in those samples. And then they try to determine if there is significant differences among the stalk and root lengths in between treatments. So ito po yung mga research objectives nila, and then yung kanila pong experimental design is rooted on those research objectives. So in this case, very simple lang po siya. So they're just measuring the stalk and root lengths using I think this certain app and the vernier caliper to measure the root and the stalk length. And in the end, they tried to see if there is significant difference between in between treatments, and of course the control sample that received no treatments. Okay, so let me just go back to my slide. So again, your experimental design answers each one of those research objectives. So the experimental design in the science investigatory projects, just like the one I showed, states why these methodologies were chosen and possibly explain why these choices were made. So kung there is a choice between one method over the other, so pwedeng students can explicitly state this in the final research paper. And the experimental methodology or the experimental design should be descriptive enough to be reproducer verified, because this also served as a basis for future experiments on the topic. So people can use this as a tool or as a basis to come up with a similar or related experiment. So the experimental design has these following steps involved. So we first define the research question and the variables involved, and we write down the hypothesis. So let's say our hypothesis for that example would be if there is significant effect of the content of these powdered eggshells into the plant growth of this certain plant, this mountain plant. And then we design the experimental treatments, and then after that we take the data or measure our samples. Okay, so these steps constitute a controlled experiment in which we systematically and accurately manipulate the independent variable. In this case, let's say the concentration of this powdered eggshells in each plant sample, and precisely measured the dependent variables. And in that example, yun nga po, how they precisely measure the stalk and root length of those plant samples. And these independent variables must be controlled accurately so that we eliminate the influence of interferences or yung tinatawag po nila minsan na confounding variables. So that we can accurately predict the effect of just one independent variable and nothing else as much as possible. So kung we are trying to see the effect of the concentration of this powdered eggshells, then yun lang po yung aspect na nagbabago. And we will see in the example on how they went about that. So here, so they said that this is the treatment, so different formulations of the soil, and this is how they measured the stalk lengths and root lengths by this app. So this is a non-standard measure of these plant parts, but they said they also use a vernier caliper. But when we are using these non-traditional or non-standard methodologies or analytical techniques, so they have to be somehow compared to standard standard methods or standard instruments. So I think they also use a vernier caliper. So somehow these authors should also included the how this app compares the measurement using this app compares with like a vernier caliper or any standard ruler or measuring device. So they also said here that the blocking of the pots were randomized every day, and they gave an equal amount of water on the different plant samples. So equal amount of watering, and also the blocking of the pots were randomized every day, probably as to control the amount of sunlight that each plant received. So we have to think about how we can control the other factors aside from the independent variable, so that the effects of interference, there will always be interferences, but at least we made some effort to control these confounding variables. Okay, we are trying to develop an experimental design. We need to develop a specific set of hard skills in order to come up with a reliable and valid experimental design, while trying to allocate our resources well. So dito na po pumapasok yung trying to optimize our resources while coming up with a perfectly valid experimental design. So I have written here three hard skills that we can develop. One is the design of experiments, experimental control, and analytical techniques. So analytical techniques will come in handy when we are doing experimental design. Of course, when our students are carrying out their experiments, so they must be trained initially on how to handle a certain instrument or how to carry out a certain analytical method. Let's say titration, or what else do we have, like measurement of a certain characteristic of that sample. So let us first dive into this design of experiment. So this design of experiment was first introduced by Ronald Fisher in 1958, and Dr. Jeffrey Bunkin already discussed this in one of our webinars in Research University. And this is very important when we are trying to plan an experimental campaign and obtain as many data points from a minimum number of experiments when we try to narrow down the number of experiments, especially when the project resources are scarce, because uh, we are very familiar with this when we're trying to squeeze in a certain budget for our research project. So we try to optimize the number of experiments so that we can obtain as many data points uh, as possible. So the way this is done is, let's just take for, this setup for example. When you want to prepare gold nanoparticles, uh, and you want to uh, get as much yield as possible with these different conditions. So you have the ratio of the precursor and the reductant on one side here. So this is the concentration of the reagents. You have the reaction temperature and pH. So you have three variables here that you want to control. So when we are trying to do design of experiments, we try to limit our conditions to bookend values. Let's say for these three different independent for these three different variables. So for the concentration of the reagents, let's say that you have 0.5 and 2.5 maximum. So these are the bookend values. And you have temperature, 20 degrees centigrade versus 70. This is the lowest and the highest bookend values, and as well as pH. You have pH 4 and pH 9. So you try to carry out experiments based on these bookend values and see how much yield you can get from these different conditions. So when you already see that the yield is highest on this, let me just get mine. If you see that you have the highest yield on this setup here, then we can optimize our experiments along this condition, and that way you already saved a lot of time and number of experiments by doing this design of experiments. So here we have only done 8 experiments, and we have already narrowed down the ideal conditions with this three different this certain condition here. Is 0.5 at 70 degrees Celsius and pH 4. So you can play around the experimental conditions along this this highest yielding condition here. And this is very important when we are trying to save as much money as possible, and reagents, and of course our time, most importantly, when carrying out experiments. And if you want to see the process, how this is done, then you can probably just search design of experiments in our website. And another hard skill that we can develop among our students is the ability to have a fine experimental control on our project. So experimental control is the ability to ensure that the measurements are reliable and valid to a certain extent, while minimizing research errors or bias. So there are two metrics here, reliability and validity of the analytical measurements or the methodology that we used. And the measure of reliability is found on how reproducible our method is. Meaning to say, when another group or another person carries out this analytical method, what is the likelihood that they will get the same results on the same sample. So dapat kayang i-reproduce or kayang ma-repeat yung experiments and come up with the same results. So that's the measure of reliability. And on the other hand, validity is secured or ensured by using validated methods. So let's say, for example, you're testing the concentration of metals in water. So a standard validated method for that is atomic absorption spectroscopy, or AAS. And that is a validated method in that if you do the experiment in the Philippines using AAS, it's the same AAS method that I can use here in Finland, and we can get the same results on an identical sample. So these validated are also so-called standard methods because they can be implemented across the board by different groups and get the same result most of the time. But of course, we may not have access to these standard methods all the time due to time constraints or budget constraints. That's why sometimes we are coming up with in-house developed methods. But as much as possible, when we're doing this ad hoc or in-house developed methods, they must be validated to standard methods. Let's say, just take a standard sample tested using these standard methods and compare the results from your in-house developed method, and in that way get a measure of the validity of that ad hoc or in-house developed method, and explicitly state that in your final research paper on how your in-house developed compares with a standard or a validated method. And also, part of experimental control is the randomization of the subjects into treatment groups. So dito na po papasok yung terms such as randomized block design or random sampling in order to minimize the errors or the bias in measurement, because when we're doing measurements unintendedly, we introduce our own personal bias, or when we carry out experiments. Even for calibration, we also introduce bias. That's why even for, let's say, doing calibration plots or calibration experiments, we try to randomize also the order of concentrations when they are being tested. And of course, when we're doing experiments, a control group must always be maintained. So this control group is the one that does not receive any treatment, from which you compare the results from your treated samples. And this must always be maintained. So when we're trying to find out available research methods for our research project, our first option should be if there are already previous research methods that were carried out already in your institution or in your school. So ang first instinct natin should be kung nagawa na dun sa university natin or sa school natin, so that that already cuts some problems with finding a research method. Let's say, as tempting as it is to find sophisticated method, let's say for metal analysis like ICP, OES, for metal analysis, if somebody has already done a research, an analytical method using AAS in your school, then that's a cheaper option. So you can already browse in the library if um, a previous research using that method has already been done, so that you can ask around if the technician is still there, or the teacher, or the professor who handled that research project is still there. So they can give you valuable insights on how to carry out that certain analytical technique or methodology for your own research. So mas matipid po dahil existing na yung research ay yung method na yon, and probably yung mga reagents are still there, or the the technician or the personnel still there to help you. So if that doesn't work, then you can browse for related research in your immediate locality or nearby province, where that instrumentation or analytical technique may be available. So dito po pumapasok yung power of inquiry na sinasabi, where you can contact institutions, let's say UPLB, if there are people there who handles such type of instrumentation or methodologies. So you can probably send an email to them stating your research project. So bigyan nyo agad sila ng background on what you're trying to achieve with that research method, so that they already have an impression that you have already a plan in mind. They only need to assist you with that technique or analytical method. So wag po nating i-underestimate yung power of inquiry. So yung third line of defense po natin na nilagay ko dito is that if these two fail for you, then probably you can search the internet for alternative methods for analysis that you can do yourself. No, kung you're trying to find like an optical method for a certain active material or an active substance, then if you find any method in the internet for, let's say, methods that you can use with just your phone, as a spectroscopy instrument, then you can probably implement that if you're already kung medyo kapos na po sa time or sa resources, then we can probably do this as our last resort. But of course, as I've said earlier, we have to ensure that this is reliable to some extent, kasi yung validated out of the equation na. So what we can do is to try at least to ensure that this is reliable when this experiment is done by another person or another group, by stating exactly what you did or the steps that you carried out doing that certain that method of analysis. Okay. So let us now tackle some of the soft skills naman. Dumayo naman po tayo sa soft skills that can be developed when we're developing a research and experimental design. So one of those is the analytical skills that we can develop among our students. And this involves, because experimental design ultimately dictates the quality of the experimental results. And therefore, developing an experimental research design can also improve the logical thinking and problem-solving skills and decision-making capabilities of our students. So dito na po papasok kung gaano sila ka-creative and ka-resourceful uh, when thinking about or coming up with an experimental design. Another soft skill that we can develop is communication skills, in that they're able to communicate the research design when they're explaining the experimental design to you or to their peers or to their supervisors and even funders or the general public. So, pagdating po ng defense, ng oral defense ng mga estudyante, then dito na po lalabas kung how well they are communicating the choice for the experimental techniques, the experimental design, why they chose to do this over another method. And this skill can help improve not only their written or verbal abilities, but also their persuasion skills when they're trying to sell this idea to, let's say, funders, or yun nga sinasabi natin kanina, if you're trying to have somebody on board from another university to help you out with the experimental design, then dito na po papasok yung communication skills ng mga estudyante. And also creativity, because experimental research involves designing and conducting novel experiments and address relevant questions and gaps in knowledge. So, dun pa lang po sa pag-develop ng research question or research idea, pumapasok na po yung creativity. But also, when doing experiments, people should think outside of the box in that when we're trying to optimize our resources while keeping our experimental design sound and effective, then doon na po papasok yung creativity ng mga estudyante natin to innovate and to come up with an outside of the box idea when trying to come up with an effective experimental design. And also adaptability. So, of course, there are many challenges when you're trying to come up with experiments or some analytical methodologies that may not be available. So, ay na, doon na po tayo hahanap ng other resources, alternative methods. So, it measures how well our students can adapt to sudden changes during the experimentation process. If one method does not work for our samples, then what shall we do? So, of course, nandiyan naman po tayong mga teachers to support our students, but we can also try and gauge our students' adaptability to this unforeseen circumstances. And of course, teamwork is there because most of the time these research projects are done in groups. So it's very important that they develop a proper coordination among themselves and with their supervisors and other parties involved in order to succeed with this research project in time and within the time frame or schedule for them to finish this research projects. So these are some of the soft skills that can be harnessed among our students. And well, of course, this is not an exhaustive list, and there's still a lot of leg room for that. So this comes to the end of my presentation, and if you have any questions, then I'd be happy to discuss them.